In the previous video we created this data set where we have the average of log healthcare expenditure per head for both men and women and across ages from 0 till 89. So the first thing we're going to do is to actually plot the outcome of that. So let's create a new code block. So we're going to be working with the age range, which is range 90, which gives me a list of numbers starting at 0, going up to 90 but not including 90, so stopping at 89. And then we're going to plot the age range against log costs per age. And now we're going to select log cost per age, sex. Let's first do males. And the variable we're interested in is log costs per head. I'm going to give it a label. So these are the cost of men. Oops. So we're going to do the same thing for females, so let's simply copy paste. So what's going to change is that this is going to be F and this is going to be female. Since we're using labels, we want to have a legend. And we can add things like X label, which in this case would be age. Oops. Oh. And we're going to have a Y label, which is going to be log expenditure per head. So then we get the plot. So in blue it's healthcare expenditure per head in logarithms for men, and in orange it's for women. So the notebook spent some time on the drop in healthcare expenditure you can see around the age of 18. Another thing that you can think about is why we have this divergence of healthcare expenditure for women in the age bracket between 20 and 40. So I'll leave that for you to figure out what's going on there. So basically what we want to do is to estimate a simple age fixed effect model. And to do that we're actually going to use a Bayesian model. So this video is not an introduction to Bayesian statistics. The notebook specifier spends a bit more time on this than I'm going to do here in this video. And the notebook also contains some references if you're interested in knowing more about doing a Bayesian analysis in using Python. And in particular we're going to be using pymc3 for this. So to specify such a model, we're first going to specify the variable that we're interested in. So that's going to be log costs per head. So we're going back to our original data frame. So the variation that we have is variation across postal codes. So we're going to do this model in the video only for females. So at home you can also try to do it for males. And if you're very brave you can try to do it for males and females combined. So we're going to be interested in the column log costs per head. And we're not going to be interested in all this additional stuff that the data frame gives us. We're just interested in the values, so that's why we specify this values statement here. And we're going to do something similar for age. So I'm defining a new variable age, which is from the data frame, where from the data frame we choose females We're interested in age, and we don't want all the rest of the data frame, so we're just interested in values. So the way you specify a model in pymc3 is to have this statement model. So we're creating a context here. We give it a name, so we can refer to it later on. So we create this model that's called model. Let me use this here, so I get the indentation right away. So I have a parameter mu. I'll explain in a second what it does. So it's normally distributed. The name of the variable is actually mu. It's drawn from a normal distribution with an average of 8 and a standard deviation of 3. And the shape, because this is an age fixed effect, I actually want to have a mu for each age, a value that I have. So it's going to be the length of h I'm going to do something similar for the standard deviation. So we use copy paste. So it's going to be sigma. Sigma has to be positive, so the distribution is going to be half normal, which makes sure that my sigma is going to be positive. So the half normal distribution only has one parameter, which is basically the standard deviation of the normal distribution that goes with it. I also want to have a different standard deviation. I want to have a different standard deviation for each age. This is not the most efficient model. I could be using a Gaussian process here or something else, but we keep it simple today. So mu h, sigma h. So alright, mu h, sigma h, and observed is equal to log costs per head. Okay, let's see whether that works. So what I've specified here is the variables that we're going to be using, so log costs per head and age. And I've set that the variable that I'm interested in, z, which is log costs per head, is normally distributed with a mean mu and a standard deviation sigma. And I'm allowing both mu and sigma to vary with h. And then I specify my prior, and I say this parameter mu is going to be, I don't know exactly what it is, but I think it's normally distributed with a mean of 8 and a standard deviation of 3. And I want actually to have 90 of these. For each age category I want to have a mu, and I do something similar here for sigma, that for each age category I want to have a different sigma. So we specified the model now. So now we can start sampling from it. So I can specify the number of samples that I want to have. Let's say I want to have 100. Oops, 100 is enough. And then with model, this is the model that we specified here. This is the same name. So with model, what I want to do, this trace is pm sample. So I'm going to sample from the posterior, and I'm going to sample the number of samples. Yeah, so again, I'm not going to be explaining fully what's happening here, so there's a bit more detail in the notebook, and there are references in the notebook. But basically I want to sample from the posterior distribution to see what my mu's and sigmas are. And actually I'm only going to be interested in the mu's. Oops, I pressed the wrong, sorry. So I want another code cell. So I'm going to plot these mu's. So they come from trace. which is the thing I'm specifying here. This is this trace. From the trace I want to have this variable mu. I'm going to be interested in the mean across the different samples that I have. So I want to have a mean for each of my ages. So I specify that I take the mean across rows, which are the samples. Then I can plot. Again, we're going to use age range. I'm going to plot mu, and I'm going to give it a label. So this is going to be predicted. And just to get an idea of the fit of what we're doing here, I'm also going to, as dots, I'm going to introduce range, the observations that we have. So that's log costs per age, where we're going to be choosing log cost per age. Sex is female, and then from this data frame what I want is log costs per head, per head, and I'm going to give this the label observed, because these are directly based on the data. So let's also introduce the legend. And then what you can see is that so the line is what we predict. So that's sort of the model that we have, with age fixed effects. And the dots are the observations that we have from our groupby statement above, so the average across postal codes. And not surprisingly, of course, the fit is quite good, because we allow here to have a different mu for each age, so we can actually perfectly fit our data in this case. So in the notebook then we use this both for 2014 and for 2011, and then we focus on how big the drop is in the 2 different years. But that's something you can do in the notebook, and this screencast should have given you enough information to actually do that.